Okay, so attendance is up if y'all want to get started. I thought I'd play this. This was kind of like fun to just watch while we wait. Ooh.
Oh. Yeah, just wait and see what's in it. Okay, that one's kind of cheesy, but I had to.
That's very thoughtful. That's very thoughtful. That's a periodic table. Look at that. It was my last day. I was like, I'm wearing my periodic table. Oh, there's socks.
Yeah.
Oh my God, there's socks. I love socks. I have the most fun collection of socks, but I do not have periodic table socks. That is awesome. Thank you so
It's
much.
just to say thank you for helping us.
Oh,
I'm really glad you wore
I want to
that.
like change my socks now.
It goes perfect with the socks.
It really does.
When I thought, I was like, she's gonna lose it.
I really want to change my socks right now.
You got the scarf?
I know, that's so I can be matchy matchy. But nobody's gonna see him. I'm just gonna know. Thank you. That's so sweet. I was so excited I was able to embed it into a PowerPoint. I was technologically impressed with myself.
When you're doing interviews in class, that app that you use, it's called Notability.
Not the one that I'm using on the screen there, the one I use the screen use, like when I'm doing recorded videos.
Like on your iPhone. So I bought it because my sister, she's having a lot of like math trouble. And every time she says it to me, I'm like, wait, what's this stuff to use? I was like, I swear I've seen it before. So I bought it. And I didn't know I could use it on my Mac, but it's also like my iPad on the side of it. There's something called like sidecar where like I can move over. And I'm like, my sister's gonna freak out when she sees this. She's gonna love it.
There's a lot of Apple to Apple can do. I don't, I mean, I'm not great at it, but it can be some pretty cool stuff.
Well, like somebody told me, because I wanted to get a pen, and everybody's like, you don't buy the Apple pen, you can buy the cheaper version on eBay or Amazon. So I bought one on Amazon for like $20, and it works amazing. I could show you.
I guess I better go start. Okay, let's see. Here we go. All right, so put the mic on. So your attendance is open, so y'all go ahead and do attendance if you have not already done so. Oh, and I got a chat. I'm sorry. Yes. Abigail, you got a question? Wait. How do I get out of this? Too much. Yes, your clicker score will be what you see on your phone. We're going to get a few more clicker questions in today, and then it'll be a combination of your participation and your performance. It won't just be one, but it'll be what you see on your phone. So this weekend, I'm going to go in and I'm going to update those grades. But there's no sense in me updating it until after today, because you're going to get some more points today. Okay, so before we start, I heard some gossip. Y'all want to hear it? So, did y'all hear that oxygen and potassium went out on a date? Y'all want to know how it went? Oh, it was just okay. I kind of like that joke. Do we need to send it to you? No, don't send it to me because I'll have it and I'll work it into an Excel spreadsheet. So it's okay. I'll update it. But on other news, right? Did y'all see in the news? They found a genetic link for people who have diarrhea. You know, it runs in your pants. It runs in your jeans. Oh my God, I messed it up. It runs in your jeans. I can't even tell a good joke. Ah. I think my delivery might be half the fun of the jokes because my delivery is so bad. So make sure you go in and do attendance. I messed up the last joke of the semester. So sad, so sad. Okay. Yes, my favorite elements are copper and tellurium because they are cute. Yes, they are. They are cute. And I've got my periodic table scarf on today in celebration of our last day of class. But your exam is going to be in this room. So you do have to come to this room. On what day?
Monday.
On Monday. You're coming on Monday. So if you look on Moodle, and you go all the way down to our final exam, we're 5T. So your exam will be on Monday from 10:30 to 12:30 p.m. 10:30 a.m. to 12:30 p.m. What's that? Yeah, set an alarm now. Do whatever you have to do to make sure. Please do show up here and please show up on time because the first person to leave determines the point where no one else comes in. Okay? So make sure you are here on time. What do you need to bring to the exam? A calculator, an approved calculator. I am not going to have extras. I'm not. And one other thing. Pencil, pen, whatever, some kind of writing utensil. Okay? I will have your exam. I'll have an exam answer sheet for you. I will have scratch paper for you. I will have your exam resources for you. But you need to bring yourself, your calculator, and writing utensil. Okay? Good on that? Yeah, okay. A lot of people were asking, what do I have to make on the final exam to get a fill in the blank, right? So I went ahead and made this exam grade calculator. The thing is that you have to download this file. If you don't download it, you can't edit it. So you follow the link, and then you download the file. And once you download the file, you can open it up and you can actually edit it. And you can determine, maybe if it opens, what you need to get on your final exam in order to make a particular score. So I just put in hundreds for everything, but let's say you had an 80. If I could edit it, come on. And it's not letting me type, but, oh, here, thank you. I was like, it should let you type. Okay, so what if you had an 80 and you had, let's say 100% on homework and you had a 80% on clicker, right? What would you have to make in order to make, doesn't matter, to make an A in the class? You would have to, you couldn't make an A in the class. To make a B, the lowest you could get, no? You could make a 70 something.
Is that percent-wise or points?
This is percent. So when you're looking, right, if you look over here, the numbers that you pull are the percentage points. So the yellow boxes there are the yellow boxes here. So just make sure you pull from the right place and put them in the right place, and it'll calculate your grade correctly. Okay? And then what's blue down here is your final grade. Okay? All right. Okay, so what else is on my list of things to talk about? Oh, this is the good news. All right, y'all know every time that y'all log in to Moodle right now, something pops up. What pops up? Course evaluation, right? Course evaluation. So that course evaluation, oh, your lowest grade has already been dropped, Haley. So your lowest grade has already been dropped. You will see all 4 when you go to your grade sheet. You'll see all 4, but one of them is not included in the calculation. So the lowest one is not included in the calculation. And you can tell if you add up your 4, divide it by 4, you'll get one number. And then you add up your top 3, divide by 3, and you'll get the number that you actually see on Moodle. Okay, so it's already been dropped. Okay, so course evaluation, right? I will make a deal with y'all. If 80% of you evaluate the course, I will give you 5 bonus points on the final exam. So I checked this morning and 5T was at 56% of the class had responded. So I can't see what you respond. I just see whether or not, what percent of you respond. Like I can look and see individually and I can see like percentage, but that's all I can see. So please, please, please use that evaluation. Tell me what worked, tell me what didn't work, you know, give me some feedback, and 5 bonus points on the exam for everybody, 80%. No, it's by class.
Yeah, I know, I didn't realize until after, because they both came up on my evaluation page.
Oh, does it come, wait, how does it come up for y'all?
We have 2, we have 4T / 5T, and then like 5.
So do the 5T. You did both. Okay, that's fine. It wouldn't go away unless you did it. Okay. I'll have to ask like IT or Moodle people how that's supposed to work. I'll find out. Okay. But 4T and 5T had different percentages. I don't know. I'll ask. Okay. And the last thing is the exam review. So I have final exam practice questions here. So what we are going to do today is we are going to do a few clicker questions, and then we're going to work on this exam review. So reviewing your old exams is a good idea. Go and see what you missed. You know, those are problems that you want to practice. Those are notes you want to go and study. Looking over the summaries, you know, studying your notes, those are effective. But I also wanted to give y'all a way to do some practice, right? Some actual problems. And so I made this exam practice questions. There are quite a few practice questions, but they're not going to be, this is not going to be the exam. You know, it's going to be similar topics, yes, the material from chapters 1 through 9, but it's not going to be exactly the same questions. And your final exam is not going to be a duplicate of your exams. So this is a good way for you to kind of see, what do I need to review? What do I need to go back? Oh, that was easy. Oh, that wasn't easy, right? And we're not going to be able to finish it all in class today, but the tutoring center is having a joint review session for Chem 109 tonight at 5:30, from 5:30 to 7:30 in Shaver Gym. Anybody going? Good, good, good. They're going to hopefully pick up where I left off. And they're going to, you know, it's the same material. So it's going to help you to be there. If you do want to go and you have not signed up yet, I think there are still spots available. You use this link, and it's a link to Sign Up Genius, and you just sign up that you want to go. But you can go and look at these answers at any point, right? Do not complete these practice problems with the key next to you. It's not going to help you. Try it without looking at the answers first. That's the only way you're going to get an accurate representation as to if you're ready for the exam or not. All right? You can have your exam resources next to you, because I'm going to provide you with that on your exam, right? I'm going to print out what you normally get on your exams, and it'll be stapled to your exam. So make sure that you have what you normally have for an exam, but don't have the key next to you. Take the whole thing, do as much as you can, then go check your answers. Okay? All right. So yeah, Abigail, I'm going to update I think you're asking about clicker questions, the final exam. Okay, so Hayden says, yes, the final exam is comprehensive. So every chapter will be on it. Will you let us know if we get to the 80%? Yeah, I'll let you know. I can send out an announcement. I'll let you know. And how many questions are on the final? I'm still tweaking the final right now, so it's going to be bigger than a regular exam. But I'm still working on that right now. I'm not really quite happy with it yet. So I don't have a final number for you, but it is bigger than a regular exam. Okay. Any other questions before we go and do some clicker questions? Get a few more points, hopefully. The exam is on paper. It is on paper. In this classroom, you actually have to see my face in person. There may be a small portion of the exam that is free response, but it is going to be a very small portion. The majority will be multiple choice. Generally, evenly, generally, not perfectly, but generally evenly. Evenly divided up between the chapters is the question. Okay, anybody else? Questions? Before we move on to science? Okay, all right. So we did attendance. Everybody should have checked in on attendance. I'm going to go ahead and stop attendance. And I hate when that happens. Slideshow. Okay. Here we go. Can move that over. All right. So our last clicker questions. Are you ready? Do you have a calculator? Y'all know that's my favorite, one of my favorite sounds, other than the psh of a Diet Coke, right? All right, looks like everybody's just about ready. Maybe. All right, so our first clicker question, Oh, move this. The name given to an aqueous solution of HBr is blank. Remember, a minute and a half. Ten seconds. Okay. All right, so the name given to our aqueous solution, is it an acid or not? Can y'all tell me that? It has to be an acid because if you put HBr in an aqueous solution, what's going to happen? This hydrogen is going to do what? It's going to be donated to the water, right? And what is our result going to be? We're going to make H3O plus what? Br minus. So if you're going to donate a proton, what are you? You're an acid. You have to be an acid. You don't necessarily have to be strong, but you have to be an acid. But this is a strong acid because I bring clay, right? So HBr is a strong acid. Okay, so how do I know how to name it? If it is HBr, this is a binary acid. So how do we name a binary acid? We say hydro, then we say the name of the element, but we end it in IC instead of IDE, and then acid. So this should be hydrobromic. Hydrobromic acid. Oh, all right. Hydrobromic acid. Okay. Can move this. There we go. Try not to cover any part of the question. What is the pH of a solution that has an H3O plus concentration equal to 8 times 10 to the negative 4? Remember, a minute and a half. Ten seconds. Oh, we're up to 37. Okay, so what's the formula that we're supposed to use? pH is equal to the negative log concentration H3O plus. So in this case, pH is equal to negative log of 8 times 10 to the negative 4. So what did you get? Good. 3.10. Good. Good. So make sure you put that negative in there. Are you going to get a negative pH? No, what's the pH range? 0, really 0 to 14. You can technically have things that are negative, and you can technically have things that are over 14, but it doesn't happen very often. Really doesn't happen very often. But basically, you can say it's going to be positive and below 14. Okay, here's a tough one. Here's a really tough one. All right. Your last set of clicker questions. I guess I'll give you an easy one. What is 1 plus 1? No, this is a challenge. This is just to see how fast you can click in, right? I had a bunch of people last class that were typing in the chat, it's E, it's E. Oh, we're up to 38. I think that's everybody. All right, I'm giving you a minute. You have to click in by minute. Make sure everybody gets their chance. I know y'all want those clicker points. They help you grade out, don't they? Some really crazy substances that you will not encounter in this kind of chemistry. Very, 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 very strong acids, very strong. Okay, here we go. All right, so let's see what y'all said. Yay, 100%. Woohoo! All right, here we go. Now you got to think about this one a little bit. An acid and a base react to form a salt and water in a blank reaction. Mia, if you want to see the breakdown, go to the syllabus. It's in the syllabus, the breakdowns. I don't remember which page. Mhm. Ooh, y'all are clicking in. I think 38 is our max, right? I don't want to close it if somebody's still trying to click in. I'll give y'all a minute and a half. I need soundtrack. That's what I need right now. I need a good song. Okay, 10 seconds. Okay, so what did we say? It is a neutralization reaction. It is a neutralization reaction. So anytime we have an acid and a base reacting and they form salt and water, it's neutralization. There's one other case for neutralization. If that acid or base contains carbon, what else is formed? A salt, water, and what? CO2. Very good. Yeah. Okay. And it is in the gaseous form. That's correct, y'all. Yes. All right. Ooh. What? I don't know. Okay, let me erase. What type of solution is one with a pH of 8? Remove this. pH of 8. Y'all look clicking in quick today. Y'all on the ball. I'll give y'all a minute. Because I think 38 was our number, so I'll give y'all a minute. All right. So what's acidic? What pH range is acidic? Anything that is below 7. So this is below 7. Basic is greater than 7. Neutral is equal to 7. What about physiological? Not 7. Close. 7.2, 7.4 to 7.6, somewhere in there, right? Depends on which system you're looking at, but, ooh, somebody had some question. When we're done with our finals, when can we expect our grades for them? By the date that grades are due. I will try to grade them as quickly as I can, but I'm not making a promise on a day. All right, so which one, pH of 7? What did y'all say? Should be basic. Good, should be basic. Okay, y'all ready for your very last clicker question of the entire year? Y'all ready for this? Remember where this has to go. All right, who is the best joke teller on the Nichols campus? Is it me? Is it Dr. Clune? Is it Boots? Or is it the Colonel? I can't believe I messed up the last joke of the semester. Never get over that. Boots is really cute. Isn't he cute? Makes me really want to get a dog. But my son's not having any of it. You know, like some kids, they're like begging to get an animal. My son is like, no, if you get an animal, I'm moving out. So I think I'll have to wait until he moves out in order to get a dog. Okay, it looks like everybody's checked in. Let us see what y'all said. You can make an exam question and joke. That's a good idea. good idea. That way I can save myself. Very, very nice. I'm so excited. Y'all think I'm a good joke teller. Y'all just want clicker points. All right. I thought that was kind of fun though. All right, so let's see if I can get out of here. Maybe. I'm like stuck. This is hilarious. Okay, how do I get out of? No. There we go. Discard. Okay. So now we can go and do our practice problems. Y'all ready? All right, so we're going to work through as many as we can, but we will not get through them all. We will not get through them all. I kind of did them in two parts because I was working on it, and then I kind of ran out of time, and then I had to go back and do it again. So instead of making everything go, I just made it into part 1 and part 2. So sorry about that, but it's all right. Okay, so the beginning's kind of a review from the beginning of the semester, right? So significant figures and scientific notation and all that fun stuff that I know y'all been missing. So what is this number expressed correctly using scientific notation? Remember, all you're doing is counting your jumps. 1, 2, 3, 4, 5, 6 jumps. And are we bigger than 1 or less than 1? We're less than 1, so we have a negative exponent. Because I will do that. I will put the positive and negative exponent. Okay. All right. Which of the following numbers contains the correct number of significant figures? So do you remember the little saying that I gave y'all? I did post the answers. So if you look on Moodle, right, and you click exam practice, I don't know why the little red thing always wants to sit right on top of. Here are the questions and here are the answers. Okay. All right. I could go back. Here we go. All right. So you remember the little thing with the United States and my horrible drawing skills? Yeah, that looks like the U.S., right? Okay. So what ocean's over here on this side? Pacific. Which one's over here? Atlantic. So this is, remember, everybody's trying to come into the United States. So that's the arrow we're going to draw to cross out zeros that don't count. So in A, is the decimal present or absent? It's present, so we're going to come in from this direction and cross out zeros until we get to our first non-zero number. That non-zero number and everything after are significant. So how many significant figures? This one's 4, so the 2 don't match. Okay. B, present or absent? Present, so we're going to cross them out until we get to our first non-zero number. How many significant figures? 3, no, that doesn't match. C, present or absent? Absent, so we're going to come in from the other side and cross out those. How many significant figures? 3, ooh, that one works. Okay, let's do the rest of them. Present or absent? Present. Well, there are no non-zero numbers. There are no zeros to cancel out, so it's all significant. So that's 3. So that's not right. E, present or absent? Present. So we come in from this way. All of these are significant. How many significant figures? 5. When you're working this study guide, it's not really a study guide, but these practice questions, instead of just looking for the correct answer, if you do that, you're going to get more practice and it's going to be more beneficial to you to kind of work through them all when you can. I mean, not every single question can you do that, but you know. Okay, which of the following conversions contains the correct number of significant figures? What's our rule for significant figures? Our answer cannot be what? B, cannot have, let's say have, more significant figures than your least significant value, right? Okay. But what about this? There's one significant figure here, 1 meter. Do we count that? Because it's a conversion factor. So we don't count conversion factors in significant figures. Remember, like I usually give you this great big long question and you're giving this child 25 milligrams of Benadryl and the stock container comes in 50 mgs per mil and you write all this kind of stuff. So the only values that you can base your answer on are things that are inside the problem, not conversion factors, right? So you have to look at those values that were in the question. And so which values were in the question? These are what you are going to base your significant figures on, okay? So how many significant figures are in the part A, the beginning, like the given information? 4. How many are in my answer in A? 7. That's not going to work. All right, B. How many in the given? 1. How many in the answer? 3. Woohoo. C. 4 and 4. Oh, so this is the correct one, but let's go ahead and still do the rest of it. And D, how many? 3. How many in the answer? Be careful. Decimal is absent, so you come in this way. So there are 2. See, this is why we do them all. Okay, and E, how many significant figures? 3. And in my answer, 2. So the only one that matched was C. Okay. Well, which of the following measurements are not equivalent? I'm going to suggest that you do it with dimensional analysis, right? So if I have 25 milligrams, and I want to go to grams, how many milligrams are in a gram? 1,000 milligrams in 1 gram. So 25 divided by 1,000, what does that give us? Okay, is our answer correct then? Yes. Okay, so that one is equivalent, so we're not going to circle that one. 183 liters. I want to go to kiloliters. I know I need liters on the bottom. We've not used kiloliters before, but what have we used? Kilograms, right? We know what kilo means. What does kilo mean? 1,000. So how many liters are in a kiloliter? 1,000 liters in 1 kiloliter. So what do I get? 183 kiloliters. So this one is correct. Okay, 150 milliseconds, and I want to go to seconds. What's bigger, a millisecond or a second? A second's bigger. Second's bigger, yeah. So we have 1,000 milliseconds in 1 second. So what do we get? 0.150 seconds. So that one's correct. All right, let's do 84 centimeters. We're trying to go to millimeters. You could convert directly to millimeters if you knew that conversion, but more than likely that's not what y'all are going to do. What's another way that you could tackle that problem? If I want to get to millimeters, I could go to meters, and then I could go meters to millimeters, right? Okay, so if I put centimeters on the bottom and meters on the top, how many centimeters in a meter? 100. 100. Milli is 1,000. Centi is 100. So we have we have in 1 meter, 100 centimeters. Then in 1 meter, we have how many millimeters? 1,000. So if you just cancel out your zeros, right? You know now that there are 10 millimeters in every centimeter, but you didn't have to know that to start out with. So what do you get? 840. Whoa, that's not right, right? All right, and the last one we'll do real quick, 24 deciliters, and I want to go to liters. How many deciliters in a liter? How many? 10. 10 deciliters in 1 liter. Okay, so what do we get? 2.4. Okay, so that one's correct. So attendance, Isabella, does not count as a grade. It counts, your participation counts. So when you click in, whether you participate or not contributes to your iClicker grade, but your attendance score is for attendance purposes only. Okay. Which of the following setups would convert centimeters to feet? I want to go centimeters and I want to get to feet. I want to end up in feet. I can't go directly from centimeters to feet. What am I going to do instead? I want to go to inches. I know I got 2.54 centimeters in 1 inch. You know how many inches are in a foot? All right, so which answer choice does that work in? That is C. Right? Yep. All right, here we go. Some application dimensional analysis. A doctor's order is 0.125 grams of ampicillin. The liquid suspension on hand contains 250 milligrams per 5 ml. How many milliliters of the suspension are required? What should we start with? So I agree to start with grams because if you're looking for 1 unit, start with 1 unit and it'll work out perfectly. If you're looking for 2 units, then you can start with 2 units. But so I have 125 grams, right? Now my liquid suspension on hand comes as milligrams per milliliter. So I can't put this in yet. I need grams on the bottom. So what am I going to do? Convert to milligrams. So I have 1,000 milligrams in 1 gram. Now I can use my conversion factor that was given in the problem. And I can say I have 250 milligrams in 5 milliliters. What cancels? My milligrams cancel, my grams cancel. I'm left with milliliters. So what do you get? 2.5. All right, really throwback. A nugget of gold with a mass of 521 grams is added to 50 mils of water. The water level rises to a volume of 77 milliliters. What is the density of gold? What's the formula for density? Mass per volume. Y'all want to take a guess on the units? How did you do that? All the answers are in grams per milliliter. Yo, when that happens, take advantage of it, right? That's telling you what the unit is that you're looking for. So use that information, right? That's good test taking skills. will we have the conversion factor? You'll have everything that's on the exam review, not the exam review, the exam resources. So everything that's there, I'm just going to hit print and staple it to your exams. You're going to have them. Okay, so my mass is what? 521 grams. What's my volume? Well, so I had water, and I had 50 mils of that water, and I dropped my gold in, and what happened to the level of water? It rose. Why did it rise? Because when I put my substance in, it took up volume, right? So the volume of my gold is the difference in the water. So my gold volume is equal to 77 minus what? 50. So what do we get? 20, 27? No. 27. Okay. Sorry, y'all. All right, 27 milliliters. And are we in the right units? That's really important. What if I gave you something in liters? You have to make sure that you're in the right units. Okay, so what do you get? $19.3? Okay. All right. Which one of the following substances will float in gasoline, which has a density of 0.66 grams per milliliter? Tell me about things that float. It has to be lighter, it has to be less dense. That's right. That's right. So remember we talked about water being so cool because it's one of the only substances on the planet where the solid form is less dense than the liquid form, which is why ice floats, which is amazing, right? Okay, so to float, we need to be less dense. So which one has a smaller density than our liquid? Sorry. We need to be less dense than 0.66 grams per mil. B, balsa wood. Right. Okay, now match the type of measurement to the unit given. So milliliter, what is milliliter? We're measuring volume, so volume's B. Millimeter, we're measuring distance. Gram, careful, it's mass. Density is going to be a mass per volume. So you're going to need 2 units on that. 125 Kelvin temperature. What are my other ones? It's Kelvin, Celsius, and the big F, Fahrenheit, big F. Okay, kilometer, distance, milligram, mass. All right. Okay, select the correct prefix to complete the equality. In 1 gram, there are how many kilograms? This one's kind of a little. G is right. G is right. 0.001 G. Because we know that there are 1,000 grams in 1 kilogram, right? So if I actually did the division, right? 1 divided by 1,000 is 0.001. Okay, yeah. All right, 16. 1 meter is equal to how many millimeters? 1,000. 1,000 is A. Okay. 1 centimeter is equal to how many millimeters? We just did the work for this one. Up. Do you remember we said 1 centimeter? We went from centimeters to meters, and then we went from meters to millimeters. We said that's 1,000, that's 100. So you cancel out our zeros and we're left with 10. So we have 10 millimeters in 1 centimeter. So that's B. Okay, 1 deciliter is equal to how many milliliters? You have 1 deciliter. How many deciliters in a liter? There are 10 liters or 10 deciliters? There are 10 deciliters in 1 liter. Okay, and then we don't want deciliters though, we want milliliters. So there are 1,000 milliliters in 1 liter. So what do? We cancel, what are we left with? 100. So which one's 100? F. In 1 kilogram, there are how many grams? Kilo means 1,000. Okay, so what is that, A? 1 milliliter is equal to how many cc's? One. So how do we read, where do you see cc's? On a syringe, right? On medicine, that kind of stuff. So a cc is just basically saying what kind of instrument you're using. You're using a syringe, but it's the exact same thing as a milliliter. All right. When a solid is converted directly to a gas, the change of state is called sublimation. Sublimation. We're going from a solid to a gas. What's a substance that you might have seen before that sublimates? Dry ice. Dry ice sublimates. What is freezing? Liquid to a solid. What is melting? Solid to a liquid. What is boiling? Liquid to gas. What is condensation? When you have condensation on your glass, right? You made yourself a nice glass of like iced tea or whatever, and you put it out and you have condensation. What state of matter is that condensation? It's a liquid. So you go from a gas to a liquid. That water was in the air. All right, in a gas, the distance between the particles is E, very large relative to the size of the molecules, right? We said that when you turn them into gases, right, they get farther apart. Typically in a solid, they're closest together, except water. Then you go to a liquid, right? You get a little bit farther, and then you go to a gas and you get even farther, except with water. All right, helium. What do we classify helium as? A what? An element. An element. Helium is an element. Okay. What is the difference between a heterogeneous mixture and a homogeneous mixture? Yeah, you can't see the different parts, but you still have different parts because it's a mixture. So this one you can see the different parts. How's a compound different? How's a compound different? How would you define a compound? It's not a mixture. So it is multiple elements. That are chemically combined in a particular ratio, right? CaG. INED combined in a ratio, right? Like C6H12O6. What do we know that's always going to be? Sugar, right? It's always going to be the same. Compounds always have that same chemical formula. And they're more than one element. Okay. Air is classified as what? What's in air? Various gases like oxygen. What else? Nitrogen. You got some xenon. You got all kinds. You got some helium. Not a whole lot. You're mostly oxygen and nitrogen. So what are we? We're D. We're a homogeneous mixture. Can you see the difference between the different gases? No, you can't see the difference. They're evenly dispersed around. You're not seeing a difference. So they're evenly mixed. And so we have these individual elements that are in this mixture. These elements are not chemically combined, so they're not a compound. Right? Okay. Which of the following is a chemical change? Cutting a rope. Chemical? No. Bending a steel rod? No. Making a snowman? No, but lots of fun. Burning sugar? Yes, absolutely. Why? Changing the chemical composition, right? We're actually undergoing combustion here. We're burning it. And so it's not going to be sugar anymore. Melting gold? No. Anytime you see a change of state, what kind of change is that? That is physical. So change of state, solid, liquid, gas, right? Don't make that mistake and classify that as chemical. Which of the following is a physical change? Baking a cake. That's chemical. Dry ice sublimating. That's physical. So you had to recognize that word as being just a state change. Fermenting grapes, that's chemical. Digesting a meal, you're eating, you're digesting, you're chemically breaking down your food. So no. And a tomato ripening is also chemical. All right. And 29, that was my mistake. We didn't do that. It's my mistake. Just X it out. X that one out. All right. Identify each of the following transformations as physical or chemical. Water evaporating, physical. Silver tarnishing, chemical. Cutting the grass. A nail rusting. This is chemical because it reacts with the oxygen in the air and makes like iron oxide. Baking a cake, chemical. Placing photographs in a scrapbook, physical. Formation of green leaves on a plant. This one's chemical. So if something happens, like just like all the processes inside of our body are based in chemistry or chemical reactions, same thing's true about plants. Everything that they do when they undergo photosynthesis and they convert sugars to energy and make things and do things, all of that is chemical, all of that. Burning leaves. What I put a C, but it's B. Okay. That one's chemical, but that's a B, not a C. Melting ice. Physical. All right, which of the following elements is a metal? Where are we looking on the periodic table? Strontium is our metal. What side of the periodic table are we looking at? We're looking at the left side. So left of the staircase. You know the staircase, that little diagonal that goes across? All right. Which of the following elements is a noble gas? What's a noble gas? The last column. That's what everybody wants to be, right? That's why they give up or they take electrons, because they want to be just like the noble gases, which is in group 18 or 8A. So which one of these is a noble gas? Argon is a noble gas. This element in this list with chemical properties similar to magnesium is what? So tell me about chemical properties. Chemical properties are similar in each column or each group, right? Similar in each group, which is a column. Why? Yep, which electrons? Yep, they're the same number of valence electrons. They're not in the same principal energy level, so they're not the same distance from the nucleus, but they do have the same number of valence electrons. So which element has the same number of valence electrons as magnesium? Strontium does. Okay. All right. Which of the following descriptions of a subatomic particle is correct? A proton has a positive charge and a mass of approximately 1 AMU. Yes or no? Yes. Yes. That's right. Yes. Sounds right. It is. An electron has a negative charge and a mass of approximately 1 AMU. Now, which part of this is wrong? The mass is really negligible. It's 1/2000th the mass of a proton or a neutron. All right, a neutron has no charge and its mass is negligible. It's really about 1 AMU, right? A proton has a positive charge and negligible mass. We said that's not true. We said that's an AMU. And a neutron has a positive charge. Nope, it is neutral, right? And a mass of 1. So it was A. The mass number of an atom can be calculated from what? Proton and neutrons, because we just said that. We just talked about up here which things had mass. Well, what two things have mass? Protons and neutrons have mass. So our mass number is equal to our number of protons plus our number of neutrons, the two things that take up mass. That's right. So protons plus neutrons. All right. So if we know that, we should be able to write the symbol of different isotopes, right? So potassium with 22 neutrons. Remember, when you write your symbol, there are going to be two numbers, one on top, one on bottom. Which one goes on top? The big one, the mass number. What goes on the bottom? The protons, which we call the atomic number, and this is number of protons. So potassium has how many protons? 19. What's its mass number? P plus N0. So we have 19 plus 22. So we have 41. Okay. Good. All right, which of the following gives the correct number of protons, neutrons, and electrons for a neutral atom of 10, 118? Sn is 10. So if we're Sn, right, we have protons, we know we're down here, that's 50. We know our protons plus our neutrons is equal to 118. So 118 minus 50 will give us neutrons. So 118 minus 50 is 58 or 68? 68, okay. So 68. Now, tell me about electrons. 50, because it says it was what? Neutral. It was neutral. So we need 50 protons, 68 neutrons, and 50 electrons. Okay. Isotopes are atoms of the same element that have what? So if we look, isotopes have to have the same atomic number, right? So we can get rid of A, and it's not E. They can't have the same atomic mass, but different numbers of protons. That doesn't work. So they have to have the same atomic number, but what's different? Neutrons. So if we have a different number of electrons, what do we call that? We call that an ion. If we have a different number of protons, then we call that a different element. Okay. All right. A sample of silicon has 3 naturally occurring isotopes. Silicon 28, which has a mass of 28 AMU. Silicon 29, which has a mass of 29 AMU. And silicon 30, which has a mass of 30 AMU. If the average atomic mass of silicon is 28.1 AMU, which isotope is the most abundant? Which one? It's going to be the one that is closest to the atomic mass that's found on the periodic table. So it's going to be A. So how do we know that? When we're getting the atomic mass of an element, it's an average. Yes, it's an average. But is it a regular old average? If I took the mass of each of these, if I did 28 plus 29 plus 30, what do I get? I get 29. But it says on the periodic table it's 28.1. So how is it different? Well, this is a weighted average. A weighted average. A weighted average takes into account the abundance. So how much of each isotope you have. And the more of that isotope you have, the closer your atomic mass is going to be to that one isotope. So basically what they're saying is it has a mass of 28 AMU, but maybe you have 99% of all the elements being that one isotope. Then your next one, maybe you only have 0.05%. And your last one, same thing, 0.05%. Divide that by 3. You're going to get a value that's very close to 28 AMU. I'm not going to make you use the formula, but you have to understand the logic behind it. That makes sense? There's a difference between an average and a weighted average. A weighted average takes into account how much of each thing you have. Yeah? Okay. So it should have been A. Okay, the number of electrons in the outer energy level of a neutral atom of boron, atomic number 5, is what? 3. How'd you know that? In the first energy level. And then you have 3 in the second. Good. Good. All right, the number of dots in the electron dot structure of carbon. How many valence electrons does carbon have? Go look on the periodic table. 4. It has 4. Because remember when we were drawing all these Lewis structures and all that, when we had to figure out how many valence electrons each atom had to give to the structure? So that's where these electrons come from. We're just drawing valence electrons, right? So let's pick another element. Let's pick nitrogen. So carbon has 4. How many does nitrogen have? How do we draw it? We just pair the next one, right? How about fluorine? 7. So you just take them individually and then what? Pair them up. Yeah? Okay. Yeah, you do have to be able to do Lewis dot. Okay. Classify each of the elements with options A through F. All right, remind me, what group are the noble gases? 8A or 18. Alkali metals. That's group 1. One easy way to remember the alkali metals and the alkaline earth, right? Alkali is one word. Alkaline earth is 2. Okay. All right. Non-metals. So it's going to be on the right of the staircase. You can't give particular groups, like you can't just say groups, you have to say right of the staircase. Transition element. It's the middle, what groups are those? 3 through 12, good. And halogens? 7. Okay, so now that we kind of know what these are, what is sodium? So it is in group 1 or group 2? 1. So it's alkali metal. Argon. Argon's our noble gas. It's in group A. Bromine. Halogen, so it's in group 7. Copper. That's a transition. So E. Magnesium. Alkaline earth because it's in group 2. And phosphorus. That one is a non-metal. So if you had to give each one of these only one answer choice, these would be your choices. Is there a choice that could be labeled by more than one thing, though, really? Our halogens are non-metals. So bromine could be, what is non-metal? C. What else? Argon is also a non-metal. Yep. All right. Ooh, nuclear stuff, right? Y'all remember this? This is not so bad as long as you remember your nuclear symbols. So what is the nuclear symbol for a radioactive isotope of copper with a mass number of 60? So in order to be copper, what must we have? 29 protons. Okay, now what goes up at the top? 60, our mass number. That one was pretty nice and easy, right? You could also write it, the other way that you could write it is copper 60. It's the same thing, right? Okay, the nuclear symbol of helium is this. This is also the symbol for designating that is an alpha particle. So you can write an alpha particle this way as well if you like. The same thing. All right, our next symbol, what is this a symbol for? A beta particle. A beta particle. Very good, y'all. Y'all are remembering some of this. So what do you need to go back and study? Your nuclear symbols. YMBOLS. I don't know why I put another Y on that. All right, what is missing in the nuclear reaction shown below? What two things are you trying to balance in any given nuclear reaction? Are we balancing coefficients like we do in a normal equation? No. What are we balancing? Our mass number and our atomic number. So our mass number on this side, 10 plus 14 is 10 plus 14. 10 plus 4 is 14. So 13 plus what is 14? 1. Okay. Now, 5 and 2, 7. So then 7 and what makes 7? 0. Whoa, what kind of particle is this? Not a beta. It's not a positron. It's a neutron. It's a neutron. It's a neutron. Okay. All right. What is the radioactive particle released in the following nuclear equation? Now this one's a little bit easier because we know the top has to add up to 159 and the bottom has to add up to 74, right? So what are we going to put over here? 4 and 2. So what symbol is this? Alpha, or what could you write? Helium. Okay, so that one is A. So, but do you need to know your symbol for things like gamma radiation? Yes, right, 0 and 0. Go back and review those. All right, let's see. A sample of cerium-141 for a diagnostic test was dissolved in saline solution to an activity of 4.5 millicuries per minute. If the patient undergoing the test needs a dose of 10 millicuries, how much of the solution should be injected into the patient? What are we going to start with? Now, you could, but if you want 1 unit in your answer, start with whatever number only has 1 unit in your problem. So what only has 1 unit in your problem? 10 millicuries, right? Okay, so now I know I need millicuries on the bottom. We have 4.5 in 1 ml. So our millicuries cancel, and we're left with what unit? Milliliters. And we know we need milliliters because look at all the answer choices. They're all the same. So 10 divided by 4.5 is a little more than 2. So it should be that one. Right? Okay, which statement is true about the radioactive half-life? E is correct. E is correct. The time it takes for 1/2 of the sample to decay. So if I started with something that was 5 grams and I went through 1 half-life, how much would I have left? This is 1 half-life. I would have 2.5 left, right? If I started with 100 grams, what would I have after 1 half-life? 50 grams. Doesn't matter what you start with. When you let 1 half-life go by, you're left with half as much as what you had from the beginning. So if Krypton 79 has a half-life of 35 hours, how many half-lives have passed after 105 hours? 3, right? 105 divided by 35 gives you 3, right? But all you're doing is going through 3 half-lives. So if 1 half-life is 35 minutes, another one is 35 minutes, another one is 35 minutes. You add these up, you get 105. So that's 3 half-lives. All right, last one. The half-life of bromine 74 is 25 minutes. How much of a 4 milligram sample is still active after 75 minutes? We're starting with 4 milligrams. Let's do 1 half-life. What was the time for a half-life? 1 half-life was 25 minutes. Okay, so 25 minutes elapses, and how much do I have left that's radioactive? Half, right? So I have 2 milligrams left. Now, I have to go to 75 minutes. So I'm going to do another half-life. Here's my second half-life. How much time has elapsed? 50 minutes, right? Well, I don't know how you want to do that. You want to say 25, and then this together is 50, right? So how much do we have after 50 minutes? 1 milligram. But we're still not to where we need to go. We need to go another half-life. And in that extra half-life, I'm going to do another 25 minutes. So from here all the way down to here, this is going to be 75 minutes. And how much do I have now? 0.5 milligrams. So just make sure you check what's elapsing. Yeah? All right. Well, good luck, everybody. The answers are posted. If you need anything, you can send me an email. I will try to get those clicker grades updated over the weekend. And I will see you back here on Monday. Anybody on Zoom have any questions? And y'all can all email me over the weekend if you need something. If nobody needs anything, I'm going to go ahead and close the Zoom. I don't think anybody's got that. Okay. I'll do this. Come on.